It's a human element periodical, and an award-winning journal for the maritime side. He's here today with his hat on as General Secretary of the Marine Accident Investigators International Forum, MAIF, which looks at the prevention and results of all investigations into maritime accidents. Dave.
Ladies and gentlemen, can I just say what a pleasure it is to be here this week, and I'd like to particularly thank IALA for inviting me this week. As Duncan says, unusually, in fact, I'm representing two organisations. First, the Marine Accident Investigators International Forum, and secondly, the Nautical Institute, primarily as the editor of their International Maritime Human Element Bulletin Alert. So, not surprisingly, I'm going to talk about marine accidents, specifically groundings, but with a human element emphasis. But first, I've got to say a word or two about my sponsoring organisations. First, MAIF, which is an international non-profit organisation dedicated to the advancement of maritime safety and to the prevention of marine pollution through the exchange of ideas, experiences and information acquired in marine accident investigation. And just very quickly, membership numbers some 70 individual representatives from over 40 administrations. Membership is open only to marine accident investigators belonging to an administration, and it's not open to commercial investigators because of the need to maintain the independent status of the various accident investigation bodies. Now, MAIF members are guided by this document, the short description of which is the Casualty Investigation Code, which came into effect in January this year. Now, the code emphasises that marine safety investigations do not seek to apportion blame or determine liability. Instead, a marine safety investigation is one which is conducted with the objective of preventing marine casualties and marine incidents in the future. Now, ALERT is the International Maritime Human Element Bulletin, a Nautical Institute project which was launched in October 2003 with the sole purpose of improving the awareness of the human element in the maritime industry. Sponsored by Lloyd's Register Educational Trust, the project is now into its 8th year, having produced 22 bulletins and gathered a large number of human element related papers, articles and presentations into its associated website database. So first, perhaps I should ask the question, what do we mean by the human element? Well, the International Maritime Organization defines it as a complex, multidimensional issue that affects maritime safety, security and marine environmental protection, which involves the entire spectrum of human activities performed by ship's crews, shore-based management, regulatory bodies, recognised organisations, shipyards, legislators and other relevant parties. So in the shipboard context, it simply means that it embraces anything that influences the interaction between a human and any other human system or machine aboard ship. Now, it's the technological revolution that has changed the way in which people and systems interact with other people and systems. And in fact, the human element of the human-machine system interface is, I believe, becoming an endangered species, partly because of the drive towards smaller crew numbers, but largely due to increasing automation. But actually, most accidents result from operator error, the root cause of which can manifest themselves in a variety of ways, and many of which can be attributed to the human element, as you've heard already from others. Now, when seeking the root cause of an incident, it's invariably the human input to the design, manufacture or operation of a system that has been a contributory factor. Not surprisingly, therefore, the accident reports produced by MAIF members indicate that the causes of maritime accidents can be linked to a number of contributory factors. You've already heard some, but let me give you some more. poor ship or system design, equipment failure through poor maintenance, seafarer fatigue, complacency, ineffective communication, a lack of attention to rules, regulations and procedures, inadequate training in the operation of equipment, and last but by no means least, an unawareness of the vulnerabilities of electronic systems. Now in 2007, the Nautical Institute conducted a study into the causes of collisions and groundings over the previous 10 years, in which human error was the primary cause. Of the groundings examined, 17% were attributable to poor or no passage plan, and 18% to poor bridge management teams. And of the cases where the visibility was mentioned, some 70% went aground in good visibility. Now, the grounding of the Royal Majesty in June 1995 is still used as a classic case study to show how things can go wrong when too much reliance is placed on the technology, and when the people who are required to operate that technology are not properly trained to use it. Now, shortly after this ship left her departure port, the antenna cable connection for the GPS receiver separated and caused the GPS to switch to the dead reckoning mode. Since the autopilot was not programmed to detect the mode change, it didn't correct for the effects of set and drift, such that unknown to the bridge team, the ship ended up some 17 miles off track. Now, during the watch preceding the accident, the officer of the watch didn't visually identify the buoy he saw on the radar, and apparently assumed that it was the Bravo Alpha buoy, which marks the entrance to the traffic lanes. In fact, he probably observed Alpha Romeo buoy, which marks the shoal about 17 miles west of the traffic lanes. Now, when the next officer of the watch took over, he didn't sight the next buoy in the traffic lanes when it was expected, and he continued to miss opportunities to avoid the grounding when the lookouts reported sighting tower lights, later determined to be on Nantucket Island, sighting a flashing red light on the port bow, which was actually the Rose and Crown shoal buoy, and sighting blue and white water ahead of the ship. That should have given him some signs. No member of the bridge team had received any formal training in the operation of the integrated bridge system. The navigation and command system autopilot wasn't configured to compare position data from other position receivers, and the officers of the watch failed to recognise the warning signs on the GPS unit, which indicated that GPS position data was not reliable. GPS receivers' brief oral alarm, the remoteness of the receiver's location from the main console, and the fact that the GPS external alarm wasn't connected all contributed towards this failure. So, the officers of the watch were relying almost solely on the GPS and the ARPA display to provide them with information about the vessel's position. This affected their situational awareness to the extent that they failed to properly identify buoys and other visual and indeed oral warning signs immediately before the grounding. Let's now look at this case of the grounding of the Bunga Taratai Satu on the Great Barrier Reef in November 2000. Now, the significant unsafe act that resulted in the grounding was the inattention of the officer of the watch, who was distracted from the navigation of the ship for a period of about 15 minutes by a telephone conversation being made by his wife, who was on the ship's bridge wing. It beggars belief. The investigation established that the ship's cross-track GPS alarm was not loud enough to attract attention, and that the absence of an appropriate level of bridge resource management allowed a basic error by one person to result in a serious accident. The officer of the watch apparently relied solely on the GPS navigator to fix the ship's position, ignoring navigation by visual cross-bearing or radar. Now, he had developed a practice of asking the able seaman lookout to plot the ship's position from the GPS every hour.